Okay, now we're going to start doing the homework. We're going to do practice A and B. Now I'm going to do, I'll do B2 first, A2, because A1 is easy, so I'll do A2. And I also have to explain directions. So it says, while following the directions on a treasure map, a pirate walks 45 meters north. Now I'm doing this mathematically. So what I'm going to do is, I'm not going to draw it exactly to scale, but I'm going to draw north, and this is 45 meters. And then it says, and then turns and walks 7.5 meters east. So from the head of this vector, I'm going to do the tail of the other one. Again, it's not to scale. That's north is up, that's east, and it says, what single straight displacement could the pirate have taken to reach the treasure? So remember, when I add vectors, I add them head to tail. This is where I started, this is where I end up. So I draw a line. Over here, at the start, is always going to be the tail of the resultant, and at the end is always going to be the head. So now I want to find the displacement, which is the resultant, magnitude, and direction. So to do that, I'm going to use the Pythagorean theorem. So R is equal to the square root of this and that. So it's going to be 45 squared plus 7.5 meters squared. So that comes out to be 45.6. Now remember, displacement is a vector quantity. It has to have both magnitude and direction. So my answer is not complete with just that number. I also need the angle. So where do I measure the angle from? You always measure the angle from the tail of the resultant. Now there's two angles here. There's an angle inside and then outside. So obviously the one inside the triangle is going to be the easiest to measure. So I want to measure this angle. I have opposite and adjacent, so that's tangent. So tan of theta is equal to opposite over adjacent. So this is equal to 7.5 divided by 45, and the meters cancel. Now again, this is going to be tan of theta. So on my calculator, when I do 7.5 divided by 45, it comes out to be 0.116. 1.1667. But that's not theta, that's tan of theta. Now normally in math class, when you want to get rid of something, you divide. So you go like, divide by tan. Well, how do you do that on your calculator? Well, if you look at your calculator, see how it says tan to the negative 1 in yellow? So tan to the negative 1 is actually 1 over tan, which is like dividing by tan. So when I have 0.1167, now on my calculator I press second, and then I press tan, and it says 9.46, so that angle theta is 9.46 degrees. Am I done? No, because I have to say what direction is. So now this is the part that you need to pay attention to. So here we have north, south, east, west. Now in this particular case, the angle's like this. Now we found this angle here. You can never have a direction from the middle of nowhere. So I'm always measuring from somewhere to somewhere else. See the way my arrow's pointing? So this angle here, this angle is actually east of north. This angle here is north of east. So it's north of east. This angle here is south of east, and this angle here is east of south. This angle here is west of south. This angle here is south of west. This is north of west, and this is west of north. So when you're talking about geographical direction, you can't just say northeast. Northeast would imply that it's 45 degrees, but in this particular case, it's this angle here, so my complete answer would be that it's 45.6 meters, and then I would say at 9.5 degrees east of north, and that would be my complete answer. So that's the way you do that. All right, let's look at practice B, and then you get to do the rest for homework. So I'll do real quick. I'll do B1. So B1 says, how fast must a truck travel to stay beneath an airplane that's moving at 105 kilometers per hour? So I'm going to first of all write my given. I see that V is equal to 105 kilometers per hour. Theta is 25 degrees. And I'm not sure what I want to find, so I'm going to draw a picture. So here's my picture. This is 125 kilometers per hour. And basically what I'm solving for here is I'm solving for the x component. So Vx is equal to V cosine theta, which is 105 kilometers per hour times the cosine of 25 degrees. So Vx comes out to be 95 kilometers per hour. So again, in these, you're just finding the horizontal and vertical components of the different vectors. So what you really need to do is you always need to draw a picture. Whenever we're doing vectors, you draw a picture of the vector, and then it's really simple to do.